Hello everyone, welcome back to my YouTube channel after 131 or so days of my absence. Today I'll be talking about a method of solving quadratic equations called completing the square. Now if you're wondering where did that come from, don't panic. I'm making a series on quadratic equations so you'll be completely filled in, even if it takes a while. Now, if you know completing the square, you can just skip this video or just sit back and relax while watching me explain this method. So without further ado, let's dive right in. So what is this completing the square? Well, it's basically a very effective method used when a quadratic equation is prime, that is, it cannot be factored with anything but 1 and itself. Completing the square always works, no matter whether the quadratic equation is factorable or not. Now, the only downside to it is really that it's a long process. So I kind of ill-advise you to use it all the time, though you should use it when your quadratic equation you're working with is prime. All right, so enough talking about what it is and all the background information and whether you should use it or not. Let's actually put it to use. So let's take a look at our first example and solve for the following quadratic equation by completing the square. X squared minus 10x minus 1 equals to 0. Okay, so the first thing you have to notice is that the x squared and the left-hand side of the equation, x squared minus 10x minus 1, is prime. It cannot be factored. So we will force it to factor by completing this square. So what we do is first we'll add 1 to both sides of the equation. So it'll be x squared minus 10x equals to positive 1. Now, this is one of the most crucial steps in completing the square. Calculate two values, b divided by 2 and b divided by 2 quantities squared, based on the quadratic equation standard form of ax squared plus bx plus c equals to 0. Here, our b value in our case is negative 10. Our c value is actually a negative c now because we moved it to the right-hand side of the equal sign. So in essence, it's basically ax squared plus bx equals to negative c. But that's not important. What is important is our b value. So our b divided by 2 will be negative 10 divided by 2, which is negative 5. And b divided by 2 quantity squared is negative 5 quantity squared, which is equal to 25. So it's negative 5 times itself. Now, moving on, we will add 25 to both sides of the equation. So whatever your b divided by 2 quantity squared value is, you will have to add it to both sides of the equation. So x squared minus 10x plus 25 is equal to 1 plus 25, which is 26. And now let's factor the left side of the equation using b divided by 2. Before I do that, let's factor it manually, like how we would if we didn't know b divided by 2. Well, normally we would do a little thought process here, like what two numbers, when multiplied, give us 25 and added give us negative 10. It's negative 5 because negative 5 times negative 5 is positive 25, but when you add negative 5 and negative 5, it's negative 10. So we know it's x minus 5 times x minus 5. But we don't have to do any of that because we've already calculated b divided by 2. So we can just simply write it like this, x minus 5 times x minus 5, which equals to 26. And to simplify it further, x minus 5 quantity squared equals to 26. So we're almost there. All we have to do now is take the square root of both sides of the equation. So x minus 5 is equal to plus or minus the square root of 26. And then to isolate x, we will add negative 5 to both sides. So x is equal to plus or minus the square root of 26 plus 5. How easy was that? Well, let's just try another example just to, get the concept a bit more clear. So now let's solve for the following quadratic equation by completing the square. X squared plus 2x minus 7 is equal to 0. This process is no different for this equation, so let's just dive right in. I'll be going a little faster. So first we will add 7 to both sides of the equation. So the constant is now isolated on the right side. X squared plus 2x plus 7 x squared plus 2x equals to 7. Now let's calculate b divided by 2 and b divided by 2 quantity squared. b divided by 2 is 2 divided by 2, which is 1, and 1 squared is 1. Moving on, add 1 to both sides of the equation, so it's x squared plus 2x plus 1, which equals to 7 plus 1, 8. And then let's factor the left side of the equation using b divided by 2. Before I do that, I know that 1 times 1 is 1, 1 plus 1 is 2, so it's x plus 1 times x plus 1, which is equal to 8. Also, x plus 1 quantity squared is equal to 8, but also we calculated the b divided by 2 value, so we didn't really have to use that, and you'll see when this will actually come in handy. Now let's take the square root of both sides of the equation. So the square root of x minus 1 quantity squared is equal to x plus 1, and the square root of 8 is equal to plus or minus the square root of 8. And then finally we will subtract 1 from both sides of the equation, and if you notice carefully, the square root of 8 can actually be simplified further. So we can simplify the radical from one of my previous videos, as you might remember. So the two factors are the three factors for 8, the three prime factors of 8 actually are 2, 2, and 2. And if you work it out a little more, you'll see that 8 is actually 2 times the square root of 2. So finally our x is plus or minus 2 times the square root of 2 minus 1. All right, so it seems pretty easy for so far, but it can get a little tricky, as we shall now see in the third example. So this is especially when we have a quadratic equation like this, where we have a negative x squared plus 6x, and then instead of a 0 or even a constant, if you will, we have a 3x minus 4 on the right side of the equation. But it's actually not too difficult to simplify this. It's just it needs a few more steps. So we will actually first start by subtracting 3x from both sides of the equation to isolate negative 4 on the right side. So it'd be negative x squared plus 6x minus 3x equals to negative 4, and then simplify that by collecting like terms. Negative x squared plus 3x is equal to negative 4. Now, we have to actually get rid of the negative 1 from the negative x squared, because, you know, x squared is now being multiplied by negative 1. And this actually also applies to any a value, really. The goal here is to make sure that your quadratic equation does not have an a value attached to it. So we will get rid of it by dividing each term of the equation by negative 1. So it'll be negative x squared divided by negative 1 plus 3x divided by negative 1, and then negative 4 divided by negative 1. And that would give us, let's see, x squared minus 3x plus is equal to plus 4. All right, so now this looks like something we can easily work out. So moving on, let's calculate b divided by 2 and b divided by 2 quantity squared. So b divided by 2 for our equation is, let's see, negative 3 divided by 2, so negative 3 halves. And then b divided by 2 quantity squared is 9/4. All right, so yeah, the negative sign, if it was on either the numerator or the denominator, you square that and you can, and it becomes positive 9 or positive 4. All right, so now let's add 9/4 to both sides of the equation. So it'll be x squared minus 3x plus 9/4 is equal to 4 plus 9 divided by 4. Okay. Now in the next step, I will actually simplify the 4 and 9/4 into an improper fraction, and you will see why later. So we'll factor the left side of the equation using b divided by 2. So this is what it looks like. So yes, x squared minus 3x plus 9 by 4 is not something very friendly for us to factor. So which is why we can now finally use the b divided by 2 value. So it's x minus 3 halves times x minus 3 halves equals 25 by 4. Okay, and then simplifying it further, x minus 3 halves quantity squared is equal to 25 by 4. Now this is why I chose to leave the right side improper fraction 25 by 4 as it is, because we will now take the square root of both sides of the equation. Okay, so this is what it looks like. So we've gotten rid of the squared on the left-hand side, and on the right-hand side, we can just take the square root of 25 and the square root of 4. So it's x minus 3 by 2 is equal to plus or minus 5 by 2. And now let's add 3 by 2 to both sides, and this is what it looks like. X is equal to plus or minus 5 halves plus 3 by 2. Now, you might be tempted to think that we're done here, but we are not, because actually this is a rational number. Okay, so if it's a rational number, then it's always the best idea to simplify these further. So we can have two possible answers, as you should in a quadratic equation. Otherwise, you're not looking at a quadratic equation or you've messed up. So our possible answers are plus 5 by 2 plus 5 by 2 plus 3 by 2, or negative 5 by 2 plus 3 by 2. So this is, after simplifying it, this is what we have. 5 plus 3 is 8. 8 divided by 2 is 4, so that's one answer. And then negative 5 plus 3 is negative 2 divided by 2, that's negative 1. So those are our two answers. Okay, so now you've seen me solve 3 examples. So why not give it a shot yourself? So solve for the following quadratic equation by completing the square. So we've got negative 2x squared minus 12x plus 18 is equal to 0. So go ahead, pause the video now, and why not give this a shot? Okay, assuming you have given this a shot, I'll give you the solution now. Okay, so we have in an a value, a quadratic equation a value of negative 2 with the negative 2x squared. So we've got to get rid of that. Okay, so we will first divide both sides of the equation, um, each term of the equation, by negative 2. So negative 2's go out from the negative 2x squared. The negative 12x is divided by negative 2. 18 is divided by negative 2. Anything, 0 divided by anything is 0. Okay, so this is what you should get. X squared plus 6x minus 9 is equal to 0, because negative 12 divided by negative 2 is positive 6. 18 divided by negative 2 is negative 9. Now let's add 9 to both sides of the equation, so we would move negative 9 to the right-hand side. So x squared plus 6x is equal to positive 9. Now, let's calculate b divided by 2 and b divided by 2 quantity squared. So here, our b value is 6. So b divided by 2 is 6 divided by 2, which is 3. And b divided by 2 quantity squared is 3 squared, which is 9. Alright, so moving on, now we will add 9 to both sides of the equation, like so. X squared plus 6x plus 9 is equal to 18. Now let's factor both sides of the equation using b divided by 2, despite the fact that we can factor this, by just educated guesswork, because 3 times 3 is 9, 3 plus 3 is 6. So yeah, x plus 3 times x plus 3 is 18. Simplify that a bit more. X plus 3 quantity squared is equal to 18. All right, we're almost there. Now let's take the square root of both sides of the equation. X plus 3 is equal to plus or minus the square root of 18. Now this is another radical, 18, the square root of 18, where you can simplify it further. So let's isolate x by subtracting 3 from both sides and simplify the radical. And if you do the math, x is equal to plus or minus 3 times the square root of 2 minus 3. All right, so there you have it. So that is completing the square. If you have any questions or alternative, methods or anything else, just put them down in the comments section below. Thank you so much for watching, and stay safe. Goodbye.